Hello friends, in this video we'll talk about different types of electron emission. Let us first see what is the problem in electron emission. You can see in the diagram that here we are having a metallic body, and from which an electron is trying to escape out. Now the problem is, as soon as the electron moves out, it leaves behind a positive potential. That means the body becomes positively charged, and because of this positive charge, the electron that was supposed to go out, it is pulled back. Now, how can we make this electron emission possible? That means, how can we make the electron escape out of this positive potential? Now, for this purpose, we have to give enough kinetic energy to the electron, and that minimum energy is known as work function of the metal. How do we define this work function? The work function is the minimum energy required by the electron to escape out of the metallic surface. This is a list of different metals and their work functions, not given in joules, given in electron volts. Okay, you can see that cesium is having the minimum work function, that is of 2.14 electron volt, and platinum has the maximum amount of work function, that is 5.65 electron volt. You don't have to remember this data, right? There are 4 different methods through which we can give the electron the sufficient energy to escape out. The first one of this is thermionic emission. See, it's very simple. A resistor is attached to a battery from which the current flows. The resistance gets heated. In turn, it will also heat the material which is covering the resistance. Okay, what are these materials? Mostly these are the transition metals. Okay, so what you have to do, you have to surround the resistance by these transition metals, and the electron will escape out when the heat is supplied to them. Now this is thermionic emission. So the electrons that are emitted out are known by the name of thermions. This is how a typical experiment of secondary emission looks like. We have a resistor which is coiled, and over the resistor we have wound a wire that is made up of some or other transition metal. The next method is of cold cathode emission, or we also call it as the field emission. See, what is happening over here is this is the metallic body, and the electron is trying to escape out. Now, as soon as the electron tries to escape out, the body will try to pull it back. But if we have very strong electric field surrounding this, how much strong? 10 to the power 8 Newton per Coulomb. This much strong electric field. Now the electrons will have a tendency to move in a direction opposite to the direction of electric field. So the electrons will experience a force in this particular direction. And if this force is strong enough, it will avoid the electron to go back into the metal surface, and thus field emission becomes possible. But there's a problem with the field emission, that along with the emission of electron, there are sparks that are caused, and these sparks can be very dangerous. What particular arrangements we need to have for the field emission? This is a simple tube light looking instrument, but it is not normal tube light. It is a tube light that is manufactured specially to make the field emission possible. Normally in the tube lights that we are using in our houses also have these type of arrangements, but this is a different one. Now the third type of emission is known as secondary emission. What is done in this? See, in secondary emission, there are some primary electrons which are thrown towards a material. This material can be steel or copper or any good conductor, right? Now the primary electrons are obtained from some other source. They are bombarded onto the surface of this metal. What will happen? They will knock out some of the free electrons from inside this metal, and these electrons will go out like this. Okay, the law followed here is a simple law of reflection. Angle of incidence is equals to angle of reflection, right? The electrons that are emitted by secondary method, they are known by the name of secondary electrons. Okay, But this method is very, the probability of this is very less. What I mean by this is that for about 50 to 60 primary electrons, there are hardly 3 or 4 secondary electrons that are emitted. So the efficiency of this is very less. This is how a particular secondary emission looks like. Coming to the last type of emission, this is known as the photoelectric emission. What is done in this? See, in this, we supply something to the surface of metal. What do we supply? We supply this H nu. You can call it photons, or you can call it even light. Okay, electromagnetic waves. These electromagnetic waves will bounce. Will not bounce, will be absorbed by the surface of metal, and it will knock out the electrons, which can be free electrons or which can be bonded electrons. Now this is a very safe method to perform, and so it has become much popular in case of electron emission. This is the schematic diagram. The incoming radiation. This is the incoming radiation. It is knocking out the electrons that are free, or it can even knock out the electrons that are bonded, right? So here we have the 4 different types of electron emissions: thermionic emissions, then the cold cathode emission, then we have photoelectric emission and secondary emission.